So would you use identities here?
You could use identities to help simplify it, but we'll have to see what the actual expression looks like, and then we can decide. So you've got 1 plus cos over sine plus sine over 1 plus cos. Yeah, so there's a denominator. You would have to get a common denominator. That would be the best thing to do. So we're looking at May, June 2017. Yeah, this one. Let's see, we finished question 3, so we're carrying on here. Okay, perfect. Right, so looking at what you've done so far, the technique is very good. You've obviously written down the question. This is 3-2, hey?
Yeah.
Okay. So first things first is to obviously write down the expression and then simplify it, if possible. 1 plus cos theta over sine theta plus sine theta over 1 plus cos theta. Okay, when I see an expression that's a continuation, that gives me a clue in terms of using what I've used before or using what I've calculated before. So if we go back to the previous question, have a look at this. What did we have here on the left hand side?
Same.
The same thing, right? 1 plus cos theta over sine theta plus sine theta over 1 plus cos theta. So see, that's a tip. When you have questions that follow on, so 3.1, 3.2, I already know what they're thinking in terms of how they set the paper, because to follow on, they're going to be using that. So what am I going to do? I'm going to take this and I'm going to write down that. Because do you agree, from question 1, from part 1, you know that this is exactly the same as that. So all I can do is just replace it. I can say this whole thing there is the same as that over sine. I can use what they've given me in the previous question, equals this, 3 over cos theta. Okay, so when you have something like this, what must you do? Take everything to one side. So I'm going to take the sine to the right, and I'm going to take the 3 to the left. So I'm going to get 2 over 3 equals sine over cos. Okay, do I know what sine over cos is? Yes, I do. Sine over cos is tan. That's your identity that you can study or remember, and then I just write that down. Right, they want you to solve. So solve means find values for theta. So now you use the calculator, you go tan minus 1, so that's shift tan. Can I check it quickly while you're busy writing that down? Okay, so let's check what this is. 2 over 3. Okay, I get that. Let's see what you get, please. Solve for theta. Yeah, so the reason why we did that is to help save time. Because you could have done the whole thing again, but then you're going to have that whole answer on that side, on that same page. Okay.
So shift 10, 2 over 3.
Yes, is 33,69. Okay, now you know what that is. Right, they gave you a domain. The question said 0 less than equal to theta less than equal to 360. Okay, what's the period for tan? 180. So this is one potential answer. If I add 180 to it, so theta plus 180 is going to give me 213,69. 213,69 is between 0 and 360. So those are the two answers. Okay, so you just have to add the period to get all the options. But if I add another 360, not 360, if I add another 180, I'm going to get 390. 390 is too big, it's outside. So the only two answers, so if they said solve the equation, you would say theta equals that and theta equals this. Two answers, 33,69 and 230,69. And that's it, that's question 2.
So would you say therefore theta equals that or that and that?
That's both.
I went through the paper and I made notes of like what they were.
Okay.
So that makes it easier.
Yes, perfect. But that's good. If you're spotting the sections and you can see how to or what to do, what the focus is, that's half. That's like basically the first step, and you're halfway there in terms of getting the answer. Okay, so here you've said.
Okay, so it says an arithmetic progression has a first term of that and a fifth term of that
100%.
and the last term of that. Find the sum of all the terms in the progression.
Good. So you've already written the formula down. That's good. That probably comes from the formula sheets. If it is there, then you don't have to study it. If it isn't there, then you do have to study it. 193. Okay, so I go to page 193, and I look for. They told you this is arithmetic. Okay, so let's write down question 4. Is this a part 1 or 2 or just one question on its own? It's just a question on its. No, it is A. Okay, so there could be a part B.
So I wanted to ask you here they gave us Sn equals half n8 plus 1 brackets equals half n2a. So I wasn't sure if they're two separate or if
they're just they're two different equations. They're like that. Two different equations, but they mean the same thing. That Sn and that Sn are the same. So you can use either or. It doesn't matter which one you use.
I thought maybe, I don't know.
There are two equations that are.
One equation because they put it equal in the middle, so that confused me.
Yeah, so they're just saying the two are equivalent.
Okay. Something else that.
Yeah, it depends on the question what information they give you. So they said here, let's write down the formula. What is the formula?
Well, I just used the longer one, half n2a plus n minus 1d.
Okay, but what did they say in the question? That's what we
Arithmetic
need.
progression has the first term of 32.
First term, so we know A is 32. Right, remember that A represents the first term. What else?
A fifth term of 22.
A fifth term, so T5 is 22. What else?
And the last term of 28.
Okay, so T, last term, L, is minus 28.
Find the sum of all the terms in progression.
Okay, good. So that's what they've given you. They've given you this, they've given you this, they've given you that. Okay, so looking at the Tn, okay, we don't know how many terms there are, but we know that the first term is 32. So we've got information relating to term 5. Term 5's formula would be A plus brackets n minus 1, close brackets d. Right, so that will be T5 equals A plus 5 minus 1 d. Okay, I know term 5 is what they said in the question, 22. So 22 equals, I know A is 32. Plus 5 minus 1 is 4 d. So I can work out the d. Let's take this to that side, so it'll be 22 minus 32. 22 minus 32 is minus 10. 22 minus 32. Yes, just double check it. Can you just check it on the calculator? 22 minus 32. 22 minus 32. Okay, that's fine. Equals 4D. So D equals minus 10 over 4. Okay, minus 10 over 4 can be written as minus 5 over 2.
Okay, let me just write that quickly.
Okay, I see here this one they rounded off to 1 decimal in the previous question. 33,7 and 213.
Okay, so that's the D. Okay.
Right, now we need to look at this TL. Okay, the T last. So we know that the last term is minus 28. So minus 28 is equal to A plus N minus 1D. Okay, I know that the last term is minus 28. I know the first term is 32. N I don't know. N minus 1. D I know. D now is minus 5 over 2.
So now we
solve for N. Okay, so minus 28 equals 32. I need to multiply all this out. So multiply that N. Expand it, so negative 5 over 2n, and then negative and a negative is a positive, plus 5 over 2. So take this across, so I'm going to have 5 over 2 here, n equals, minus 28 on this side becomes plus 28 on that side. So 32 plus 28, that's 40, that's 60. That's 60, and then plus 5 over 2, 5 over 2 is 2.5, so it'll be 62, 5. And then n would be 62, 5 times 2 over 5 to get rid of the 5 over 2. So n equals, okay, you work it out. 62, 5 times 2 over 5 is what?
25.
There we go. Okay, now we've got
that's term number 25.
No, n is 25. So there's 25 terms in total. Because they said this was the last term.
So the last term is
the last term. Yes, the last term is the 25th term, and the last term is minus 28. Okay, so now you've got the whole sequence basically. Right, the last step is to answer the question, which they said is find the sum of all the terms. So then we just use that other equation, because then we've got everything. Just substitute the A, the D, the L, and all that.
Okay.
Right, then the last step is to use that equation. So now I want the sum of all the terms. Okay, Sn equals n over 2 brackets a plus l. Okay, that's the easiest one to use because you know what the last term is.
I don't have that one here. I have half n brackets a plus l.
Yeah, that's the same thing. So that's a half n.
Oh, okay.
Okay, so n we know is how much? 25. Right, which is a half 25. A we got as what? Let's go back. A was 32 plus last term was minus 28.
Can I just bring the calculator?
Yes. Let's see what you get. Correct. And that's it. Right, so the tip is always to read the question and pull out the information and then solve for things that you need.
Okay. Then over here it said each year school allocates a sum of money for the library. The amount allocated each year increases by 2.5% of the amount allocated the previous year. In 2005, the school allocated $2,000. Find the total amount allocated in years 2005 to 2014 inclusive.
Yeah, so this is again a sequence and series type question.
Would it also be an arithmetic progression?
Well, it's increasing by 2.5% every year, so it's multiplication. So to me it's geometric because you're multiplying. Okay, it's 2.5% of the previous year. So you're multiplying. Yeah, but let's first write down things and then that'll confirm it for us. Okay, so they said the amount allocated each year increases by 2.5% of the amount allocated in the previous year. They said in 2005, so we need to write that down. 2005, how much they allocate? 2,000. Find the total amount allocated in the years, so 2015 all the way through to 2014. Okay, so they want to know what the sum is. That's what they're asking you to do. Okay, so they tell you this, and then they tell you that every year it's going to be plus 2.5% of the previous year's amounts. So every year you're going to be adding 2.5%, 2.5%, 2.5%, 2.5%. Alright, so let's go to the geometric series. Okay, so your Sn is the sum. You've got different equations here. Geometric, you need to work out A. A would be the second term over the first term. The R, not the A, the R. A is the first term. So let's write this down. Tn equals A R n minus 1. And then you've got the other formula. Is this on the formula sheets?
Yeah.
Okay, then you don't have to study it. Okay, just use it. A bracket 1 minus Rn over 1 minus R. Right, so that's what you've got in terms of the geometric formulas. And we're obviously looking at what's happening every year. So what is happening every year? It's increasing by how much? 2.5%.
Yeah.
What is 2.5% as a decimal? 0.025. Okay, so let's write down the next thing. The sum of all the terms. How many terms do we have? So if T5 would have been the first term, do you agree? So 5 would have been 1. Then 6, so 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 10 years. So this would be T10. Right, so 5 is 1. 6, 7, 8, 9, 10, 11, 12, 13, 14, yes. So term 10 is T14. Okay, so S10 equals A. What is the first term? 2000. I'm using the formula. Multiply that by 1 minus R. What is R? 0,025 to the power 10 terms over 1 minus 0,025. Okay, plug that into the calculator and let's see what you get. Be careful, your 10 here is inside the bracket, not outside the bracket.
I did it right.
Okay. It does make a difference.
That's my answer.
Is 2015.
2051.
Let's see how you substituted it in. Oh, you forgot to put the 2000 outside. It's 2000 times. So it's 2000 times open brackets, then numerator denominator. So it's 1 minus 0.025 squared. Close that bracket. All over 1 minus 0.025. There needs to be a bracket here. Brackets. This is 5 and then brackets here. Notes. Syntax error. Why? Oh, maybe there's a bracket here. Brackets. Calculator says error. Let's see why. Maybe put more brackets. Bracket equals. Still syntax error. Why? It's O to the power 10, not to the power 2. Still error. 1 minus. Oh, maybe there's too many brackets. Delete. There we go. Okay, so decimal. Okay, you got the same answer, yeah. 2051,28. Okay, look at their answer. They've used a different formula. That's not the right formula. Okay, look at your sum. There's the right formula. See? Sn equals A brackets 1 minus Rn, 1 minus R. They've turned it around. They've used Rn minus 1, not 1 minus Rn. That's wrong. See that? Okay, they've used the wrong equation to work out the sum. Okay, so there's a mistake on the memo. That's not the right equation. That's the right equation. Okay, so don't look at their answer. It's not correct.
Is this also the same as this equation here? Is it just like two different ones?
No, this is infinity. See, there's a little infinity sign. Yeah.
So when would you use this in what case?
When you're looking at numbers to infinity. Okay. Yeah. I don't think we looked at those questions, so you probably don't need that formula.
Yeah, that's why I didn't recognize it. That's why I put a circle around it.
Yeah, it's just a generic formula sheet. Remember, they probably give this to the A level students as well. So you're doing AS, so we limit the scope to what you need to cover. Okay. Yeah, so that's the answer. We've used the right formula. That's the right equation. Okay, not what they've done in the memo. So even the memo, they say here, formula with n equals 9 or n equals 10. Okay, there is no option here. N is 10, not 9. Okay, but they say mark it correct if they put 9 or 10. I don't know why, that's strange. Okay, there is no option here. It's not 9 or 10, it's 10. That's it.
So is that the answer done?
Yes.
Such a big space for such a small space.
Well, it's only what, 3 marks, yeah. Okay. Yeah, next.
And the next page was trig graphs. So
Okay,
the equation of a curve is y equals 2 cos x.
We need to write that down. Y equals 2 cos x.
Sketch the graph of y equals 2 cos x for the domain, which is minus pi and pi. Starting the coordinates of the point of intersection.
Less than or equal to, yeah, less than and equal to. And it was x. Less than or equal to pi.
So what does that really mean? When I see that, I don't really know what it means for like a graph.
Pi is just radians. Okay. So it's writing down a degree in a different format. Okay, so I would convert this into degrees.
Can I just put it in my calculator? Or
no, you have to use that formula. Okay. There's a formula to convert radians to degrees and degrees to radians. Yeah, you can't just put it in the calculator, you have to. Okay.
So do you want to do that now then?
Well, let's just read the rest of the question. What else?
Starting the coordinates of the point of intersection with the y-axis.
Oh, that's all. Okay, so that's quite easy. Obviously, you're starting at negative pi. Okay, so we need to do the conversion. We need the textbook or your notes, either or. Just go to the radian section, and we just need that formula. It'll probably be part of trig if you filed it that way, but it's the radians, yeah. So the radian notes. We just need that formula to do the conversion. I think it's 180 over radians equals 180 over pi equals radians. I think. I just want to make sure. Yeah, we need the radians, just the conversion. Now, that's just normal trig stuff. It's a formula. I think it's 180 over pi, but we need to check.
The radians must be used.
Do you have the word program?
Oh no, I don't have that small.
Okay.
Should be my textbook.
Right, if the textbooks are there, we can just check this.
Textbook 1 2.
1. Okay, perfect. Right, so let's see what that formula is to convert radians and degrees. Radians. Solving for trig equations, 292, 1 and 284. Let's go to 284 first. Let's see if it's there. Okay, there's it. It was slightly different. It was pi radians equals 180. So this is what we need. This is what we need to study. Pi radians equal 180. So they've given you a few notes here. 180 is pi, so this would actually be 180, and this will be minus 180. Here we go. Okay, because it's pi radians. Okay. Right, so you've got negative 180 to 180. So it's actually an easy conversion if we just looked at the little bit over here in the textbook. Yeah, so page 284 gave you the conversion. Because they said pi radians equals 180, I know pi is 180 degrees. So I've done the conversion now. Now we can draw. But when drawing, we need to use radians, not degrees. Okay, so that's the key one. We can just look for the key points. Okay, so when drawing a graph, let's wrap out this. We don't need this now because we know what it is. Okay, let's draw the graph. Starts at 0. I'll have minus radians, which is the same as minus 180. I'm going to put both here so you can see it. And then I've got 180 here. And that's for positive radians. Right, so half radian, half pi would be 90. And negative half pi would be minus 90. Okay, because remember, 180, 90, those are the key angles. Okay, you're looking at cos here. Right, and this is obviously 2 cos x. Okay, so everything will be multiplied by 2. So we also need 45. Okay, and we need the one in between here, which is 135. Minus 135. Minus 45. This would be 45, and this would be 135. Okay, in terms of a radian, can I get your calculator quickly just to work out what the relationship is? So 180 over 45 is 4, so this will be a quarter. This will be pi over 4, and 135, so 180 divided by 135 is 4 over 3, so this will be 4 pi over 3. Right, so negative 4 pi over 3, and this will be negative pi over 4. Alright, so those are the key points. I'm just looking at radians and degrees. I want the degrees obviously because that's the easy one. Okay, then I just need to substitute in the calculator. So I go like this. What's the formula? Y equals 2. So it's 2 cos x, or whatever x is. So I want points. Let's start at 0. Brackets. Okay, it's 2. So let's put that here. Let's put a point. 2. Okay, I want 45. Delete 45. Gives me root 2. What is root 2 as a number? 1.4. So root 2 would be 1.4, maybe here. Okay, let's put in 90. Gives you 0. Put in 135. Gives you root 2, negative root 2. Negative root 2 as a decimal is negative 1 over negative 1, negative 1,41. Okay, so somewhere there. And then this one is probably negative 2. We'll check. 180. Yes, negative 2. And then it goes here, negative 2. Right, so now we're going to draw that. So this will go like this. Okay, and then we need to do the same thing on this side. So it'll be mirror image.
If we had to just do it in degrees and not put the radians, would they mark us down?
Yes, they probably will, because they said the domain was minus radians and radians. Right, so you can convert. I would put both like this, because then you've got this and you've got that. They have to mark it right, because you've got both. You've done the conversion as well. Okay, then obviously it's mirror image, so then this would be here. Then this would be 0, and then so 90, hold on, 45, ooh, my point's on right, missed the point. Okay, so there's the point, and then 90, and then 35, and then minus 2. Okay, I need to put back the, okay, let's just draw it quickly and then I'll change the color. Just to draw back the line. I rubbed out the line. That's it. There's it. Family. 2 marks. Wow, 2 marks. All of that.
It's a lot of work.
Yeah. Okay.
I just wanted to ask how you got these again, because I think I would struggle to get these. Like obviously that's 180, then you get a half by 90.
Okay, so
but how do you get 4 over 3 and 4?
Yes. Okay, so alright, so we know that pi radians equals 180.
Yeah.
Okay, so that's why I've got a negative 180 and a positive 180.
Mm-hmm.
Okay, so if I've got 180 as a radian, obviously if I divide this by 2, I'm going to divide that by 2. So pi over 2 would be 90. 180 over 2 would be 90. Same thing.
So pi.
No, you don't substitute pi in.
Over 2 equals.
Yeah, you don't put pi in because pi is a radian. Okay, so pi is 180. Okay, it's the same. Pi radians is 180. So if I divide, so radian is 180, negative 180. Okay, if I divide by 2, what's 180 divided by 2?
90.
90. So pi over 2 would be 90. Alright, so pi here is not normal pi. Pi here is a radian. Okay.
And then to get 135?
135. So then I just went 180. Okay, so let's work out this one first. Pi over 4. Okay, do you agree if pi equals 180? 180 divided by 45 would give me 4. So that'll be 4. Okay, so it'll be pi over 4. So pi over 4. So if I divide pi over 4, so if pi divided by 4 is the same as 180 divided by 4. 180 divided by 4 gives me 45. Okay, so I'm just dividing it by the number. So to get the 4 over 3, 180 divided by the number, 135, gives me 4 over 3. So 4 over 3 pi would be the same as 180 times 4 over 3. So see, 180 times 4 over 3 is
180 divided by 6 times.
180 times 4 divided by 3. That gives you 135. I think this conversion is not right for this one. Let's just double check it. 180 times 4, because this would be, let's try it again. 180 times 4 divided by 3 is 240. So I think this one's not right, this middle one, this 4 over 3. The conversion here is not right. Let's fix the conversion. Okay, so we know, let's just put this in. Let's write it down. Okay, we know that pi equals 180. Okay, I want to know what 135 is. Question mark radians. So if I want to take the 135, so it'll be 180 over 135. 180 over 135 gives you 4 over 3. So it should be 3 over 4, the inverse. 3 over 4 pi equals 135. Let's check if that's right. 3 over 4 radians would be 3 over 4 times 180. 3 over 4 times 180 is 135. Okay, so I just had it the wrong way around. Okay, so let's put that in. Should have been 3 over 4, not 4 over 3.
So you'd have to inverse it.
Yes. Okay, so basically it's an equation. So this is what I had there. Pi equals 180, question mark pi equals 135. Right, solve for that. Okay, so then I had to 180 divided by 135 gave me 4 over 3. If I inverse it, I get 3 over 4. So see, 3 over 4 times 180 gives me 135. Okay, so 3 over 4 pi equals question mark. What is pi? 180. Okay. So it's just playing with numbers to get those expressions with radians. Right, to answer the question, all you needed was that graph, okay, with the degrees. It's easier to work with degrees, that's why I like converting it, okay.
As I practice getting the radians, so you say 180?
No, 2 cos bracket x. Oh, you want to get the actual thing, that's fine.